14 weeks of material into about 12 weeks because the last 2 weeks are lost. Okay, and I'm recording. Yeah, okay. Let's talk a final exam. Exam. Right there. I have on my schedule, your final exam is 26 May at 12 p.m. Is that what you see on your schedules? Yeah, okay. So today is the 4th, so you got 22 days. You got 3 weeks before the final, so you got plenty of time there. And what my plan is, I'm going to do, this is really my last class that I've got planned. Next week is really just kind of make up any questions you have, any labs you're missing that we can do next week. So I really have nothing planned. So if I don't hear from anybody, I'll show up to class. If nobody shows up, that's fine. Don't worry about it. I'll just I've been marking attendance since everybody's here anyway, so I shouldn't record that to say because that's against UniKL policy. I'm supposed to take attendance every time, and if you miss more than 10% of your classes or 20% of your classes, you get barred from the final exam. I come from the U.S. and we typically don't take attendance in our classes. If you can pass the final exam, you get all the labs in, we still pass you in the course. I don't care, most of the instructors in the U.S. don't care if you don't show up to any class. And actually a class like this where I record most of the lectures, I've had students in the U.S. that have never shown up to a class. They'll show up during my office hours and ask questions, or they'll email me with questions, but they just don't show up to class right there. And there's legit reasons in the U.S. because a lot of people work full time, and my phone keeps, I need to put this thing on. I keep getting these iCall messages, so I don't care about those messages right now. All right. So the final exam, the overview of the final exam is there's 5 questions. I'm going to tell you what the 5 questions are. Of course, I'm not going to tell you the exact questions, but I'm going to tell you what each of the 5 questions are in each of the parts, so you know what to study for there. You answer all questions. This is not a final exam where you pick 4 and leave 1 blank. You have to answer all 5 questions. All 5 questions are tied to a single course learning outcome. So when I submit my learning outcomes report, I'm just going to use these final exam questions to go back to and say, all right, if they did 80% on this question, 40% on this question, that's how you did that there. Because I have to give a report at the end of the semester saying how well I think everybody did on that there. So that's different than your grade that there. So, okay, that there. Question number 1 is on the 8051 in particular, but it's in this final exam is a little bit different. But I'm going to tell you question number 1 gets into that there. The first question, I'm just going to tell you what it is. What's the difference between a microcontroller and a microprocessor? So, micro P versus micro C right there. What are the differences right there? So, the second part of the question is the addressing spaces on the 8051. The 8051 addressing spaces. I'll tell you right now the answer is there's 3. There's external data there's internal data, and there's code memory. Those are the 3 addressing spaces there. These are the addressing spaces. There's 3 different addressing spaces. There's code memory, where your code goes. There's the external memory, and then there's the internal data memory. There's two types of data memory, internal and external. Now remember that some of the internal, some of the external memory is actually physically on the chip, but we call it external memory, right there. You need to know what each is used for. So you need to know the 3 addressing spaces. I'm giving all the answers to the final. This is a bad class to miss. That there. So, that there. So again, quick review for our latecomer there. Question number 1 has got A, B, C, D, E, and F. So there's, and what happened there? It looks like there's 6 parts of that there. One part is difference between a microcontroller and a microprocessor. The second part deals with the 3 addressing spaces. That there. The third part of that gets into I'll just read this. Give an example of instruction uses each of the following memory addressing techniques. That there. And I list 4 or 5 of the addressing techniques. So, addressing instructions. Now, those were covered in a particular set of slides. Oh, everyone's showing up today up there. Must have heard I'm reviewing for the final, right? Up there. So, there's a set of slides that I went through. I posted on Facebook. I'll just point them out. Lectures, and I think let me go through the slides and show you where I didn't talk anything about Harvard von Neumann. I did cover that in this class. Right there. It wasn't in lecture 1. I thought it was lecture 2. Now these don't correspond with our lecture, what lecture they were, but right there. This is the slide on the memory organization. Remember I said there's 3 different memory spaces. That's coming directly from this slide right there. So one of the questions parts of question 1 comes directly from this slide right there. So, right there. And I should give you a little hint. The internal data memory is where the special function registers reside. That's one of the things that and the registers reside in the internal memory. External is just for general purpose use, and program memory is used for programs. Right there. Right there. And you see this goes into more detail on the I ports. The crossbar, you need to know what the crossbar is and what it's used for. That's later on. Right there. And tool stick platform, that there. It's actually the instruction set. This is an important set of slides right there. Because this particular set of slides, there's the addressing modes I mentioned before that you need to know and instruct how to use each of those addressing modes. I said I was going to give 4 or 5 of those. I already read the question. The question is, give an example of an instruction that uses each of the following memory addressing modes. And there's the long list of memory addressing modes. I'm not going to list all 10 of those in the question. I'm going to pick 3 or 4 out of that list right there. Right there. So those are the addressing. And as you go through here, you'll find that this particular set of slides gives an example of each of the addressing modes right there. So a lot of the first question comes out of this lecture right there. I'll just tell you right there. This is lecture 4 on the 8051 instruction set. I know I posted it on Facebook. If you can't find it, WhatsApp me, message me through Facebook or whatever, and I'll repost them right there. But that's an important set of slides right there. So, okay, going back to right there. That was part 3. Part 4, 4 and 5 are specific instructions that state write the instruction to do X, Y, Z. So you're going to be given that it may be to move data, it may be to add 2 numbers, but it's going to be write the instruction right there. So you have 2 parts of that question that are write the instruction to do something. So you write an instruction. I will tell you right now that one of the questions is going to be using internal data memory, the other one's going to use external data memory. They're very similar questions to each other. It's just that one is going to be using external memory and one's going to be using internal memory. The difference is that if it's an external memory, you use the move X command. If it's an internal memory, you use the move command. If it's immediate data, in other words, if I tell you to move or add a particular number, you have to put the number sign in front of it. If I tell you it's going to be from an address, then you don't put anything right there. And if I tell you that the data is in a register, or the address is registered, you have to use the @ sign right there. So again, it's very similar to the question 3. Question 3, I just say write an instruction that uses indirect addressing right there. Write an instruction that uses direct addressing. Write an instruction that uses immediate addressing. Write an instruction that uses relative addressing. That there anything on that list that there that of the 10 that there. Questions 4 and 5 are specific instructions. I'm going to tell you to move data from one location to another, or I'm going to tell you to add memory to the accumulator. That's stored in a certain place, or that there. And then the last part of this question is I give you a program, you're given a segment of code, and you have to trace through it. Oh, I got an error in there. If you see an S-move instruction on the final exam, that's just a move instruction. I just realized that there's an error in the final. This thing, they make me reformat it so many times. So there's a command that's probably going to show up saying S-move. After I think I got time to catch it before I print the final and fix that there. But I give you a section of code where I'm going to move some stuff around, load some stuff into registers, do some adding, subtracting, or whatever, and you have to go through and tell me what the registers contain after the code is executed. So basically, it's going through and seeing if you could follow a small section of code right there. So that's problem 1. That's a pretty good sized problem, right? Right there. As you can see, that covers a lot of the basics. Problem 2. And my handwriting is bad. Right here. Problem 2 basically deals, the first part, A, is going to deal with clocks. And I'm not going to necessarily tell you the exact instructions, but they're basically asking questions, why do we use certain clocks at certain times? Right there. In other words, when would we use an external clock? Hint, when we need high accuracy. I mentioned many times that the internal clock is plus or minus 20%. So I'm going to ask you, why do we use an external clock? Well, the answer is the internal clock is only plus or minus 20%. If you need more accurate timing than that, then we have to use an external clock. If we are going to use serial communications, which requires accurate timing, we have to use an external clock. So that's there. Why would we lose a low frequency clock? Well, power consumption increases exponentially as you increase the speed of the microprocessor. So if you want to go with a low power application, you would use a low frequency clock right there. So there's multiple clock questions out there. You don't have to write any code for the clocks. but you have to know when we use certain clocks right there. So this is dealing with clocks, and the big question is why a certain clock is used and when, right there. So again, I'm not, as I mentioned before, I don't really want to get in too big a detail on how to use this particular microprocessor, but every microprocessor or every microcontroller has multiple clocks available to it right there. And so why would we pick one clock frequency over another? Why would we use an external clock versus an internal clock? That's what I'm looking for, is the why. Not the how, but the why right there. So the next part of this question, and this is only a two-part question. Part A's got multiple parts. Part B has only got one part, and that one is memory addressing. That's the one I spent, I think, 2 class periods going through examples of circuits where I had the 8086 and all the address lines and said, what's the address in this particular, chip? What's the address range of this click? That's that question right there. That is I spent a lot of time going through how to answer that question, so I'm not going to go through it again. But that's that question that I spent, I think it was last week, I spent both class periods going through that particular question. And as I recall, I said the reason I did that was because I covered it early in the semester. Everybody forgets it before the final exam. So part 2B is that question. You're going to see a circuit drawing, and then you're going to have to tell me what memory addresses are in what memory device right there. And I can tell you right now, I'm looking at this right here. I've got 3 different memory devices. The question is, determine the memory address of the 3 memory devices connected to an 8086 as shown in figure 2. Actually, it's an 8088, but that's okay right there. Because I showed D0 through D7, and then I show A0 through A14 right there. And then A18, A19 go to my decoding logic circuit right there. So you have to analyze the circuit, so right there. So again, what you're going to see on that problem is you've got A19 through A15 going through some circuit right there, 3 chip select lines coming out, going to 3 different memory devices, and you have to analyze this as well as look at how much addresses, what the addresses are in each of those 3 devices. And I did an example, 2 examples, I think, out of the textbook last week. This problem is no more complicated than what I did. I will give you a hint. I do use a 138 in the circuit, a 3 to 8 decoder. So it's not a real simple one, but it's not real complicated. Right there. There's a single 138 there. And I use some of the address lines to select that particular chip. That's it. Problem 3. What's the purpose of a watchdog timer? I'm just telling you right off, that's the question. What is the purpose of the watchdog timer? What does it do? The watchdog timer. Yeah, it's called the watchdog timer. What does it do, and when do you need to use it? Right there. So the watchdog timer is a part of the 8051 processor. It's not in the 8086. However, almost all 8088 circuits put a watchdog timer in, but it's an external chip right there. But what is the watchdog timer, and what's its purpose? Now, the watchdog timer, I'll tell you the answer. You should be right there. Is a circuit that if you don't tickle it every so often, in other words, you don't write to it every so often, it will reset the processor. And the purpose is to prevent the processor from locking up. right there. And it's used in critical areas. I use, the example I've given is a heart rate pacemaker that keeps your heart beating at a certain rate, right there. In other words, there are people I know, I don't have one, alhamdulillah, but I know people that have them. It's a little electronic device that's microcontroller, controlled. They actually surgically implant it inside someone's chest. It has 2 wires, 3 wires attached to the human heart, and the purpose of this is to keep the heart beating at a constant rate, because that particular person's heart doesn't beat properly. That's a fairly important piece of equipment because if it locks up and fails to tell the heart to beat, his heart stops beating, right? And I pretty much guarantee that nobody's going to be around long if their heart stops beating for very long, right? And if a person has a pacemaker installed, it's because they've had problems with their heart stopping. I don't think a healthy young person like this gentleman here can cut him open and put in a piece of electronic hardware to tell his heart to beat, right? Unless he's got a problem, So something like a pacemaker, you would definitely want a watchdog timer because, if that circuit fails to work, the person dies. The controller that's, say, an ARM microcontroller, which is what they use on a Airbus 380 aircraft jet engine, if that particular controller malfunctions and shuts that engine down or throws it at full throttle while flying across the Pacific Ocean, not one person dies, 200-300 people die. You might want a watchdog timer on that microprocessor. The whole idea of the watchdog timer is to prevent catastrophic failure if that processor fails, right there. It resets the processor if it locks up, right there. So, again, that question is on the final exam. I just told you the answer. Now you got to figure out how you're going to put that in words right on the exam. Don't write a book. Just simply, the watchdog timer is used to reset the processor in case of a hardware failure or a software glitch or something like that. In other words, you just write a simple, give an example where you absolutely need to use a watchdog timer, and just simply say one of the 2 or 3 things I told you right there. So again, what I'm looking for is not how we use the watchdog timer, but what it is and why it's used right there. That's what I'm trying to get across in this class. And unfortunately, we did not do a lab on the watchdog timer. I think I'm going to add that to the microcontroller course so you'll probably see a lab on the mic there. But the idea of the watchdog timer is that it resets the processor if you don't want to do. As you recall, every lab we did, we put 2 instructions that first thing we did was we turned off the watchdog timer, right? Because we didn't want to bother with it. None of our simple little add 2 numbers, multiply 2 numbers, blink the light, none of those labs were critical right there. If our processor locked up, we didn't care, right? We just hit the reset button right there. Same thing with your phone. Your phone locks up, you don't care, right? You just turn it off and turn it on. Nobody dies when your phone locks up right there. You're running Windows and you get the blue screen of death. Not the end of the world, right? You just turn it off, turn it back on, right? Your heart pacemaker that's inside your chest, you can't go in there when you're having a heart attack and reset the processor. So there better be some safeguards to reset that processor. So that's parts, actually. Okay, wait, hold on, I lied. This is still problem 2. Problem 2 has more parts. I just read the page. This is still problem 2. This is problem 2, part C. Problem 2, part D is you're given an 8086 and you're asked what the following lines mean right there. I'll just read the problem, but I won't tell you the lines, just as I did with the other one. the question is, explain the purpose of the following lines on the 86 shown in figure 3, right there. And I list 4 lines, and I don't know why it starts with 3 and goes to 6, but that they're supposed to start at 1 and go to 4. But Windows did its little thing and continued numbering from the previous list up there. And I show you a picture of the 86, and I list the lines right there. And I know that I covered that in class, but that goes back to the Bride book, where there's a whole list of all the lines on the processor, what they are, you know, things like reset, interrupt request, interrupt acknowledge, all those lines, that they're all there. There's a list of 40 lines there, and I pointed out that you need to know what they are right there. So that problem is, and some of them are obvious at there. I mean, in other words, if one of them is reset, you probably should be able to guess what that one is at there. But most of them are pretty obvious. Now we're to question 3. I thought question 2 was awfully short. Right there. So question 3. Now we're into question 3. Now we're into question 3. Problem 3. Okay, there's some terminology that the first part of this question deals with subroutines and interrupts, and I just asked some terms right there. You know, what is an ISR? What is an interrupt vector table? What is the return address? You know, those types of things that there. So you just simply need to know the terminology dealing with that. And most of that question, not all of that question, came from this lecture here, lecture 8, right there. There's more from this right there, but again, some of the terms that came from there. But it's relatively that there. And then I'm going to put a couple of lines of code there that also deal with interrupts, and I ask you, what do these lines of code do? Right there. Again, if you understand interrupts and how they work, you would understand what those lines of code do right there. So, and then the last part of that is what happens when an interrupt occurs. Explain the process. And that goes back to this diagram right here. I mentioned this diagram when I lectured it. In other words, 10 points on the final exam, and this is an absolute gift to everybody, can occur. You will earn the 10 points if you can reproduce this diagram right there. Essentially, this is a gift. I'm going to read the problem, and it says, show and explain the process that occurs within the microprocessor when an interrupt occurs. That's the question. This is the answer right here. This is the answer to that question right there. So here's your gift for the day right there. And that's worth 10 points on one of the problems. Just knowing what happens when an interrupt occurs right there. And here is the answer right there. So that's problem 3. Problem 3 is short. It's got 3 parts right there. Parts A, B, and C. And A is some terms. B is, I didn't really give you much, but just 2 lines of code. If you look at Blinky or any of the code, you should understand what those 2 lines do, especially when you look at, if you understand the interrupt process right there. If you understand interrupts, you'll understand that there. And then the third part of problem 3 is this diagram right here, knowing this diagram. What happens when an interrupt occurs right there? And I'm telling you that the answer is right here in front of you in this slide right there. Problem 4 is much more difficult. Those are the easy problems on the test. Right there. Now remember, to pass the course you need 60%, right? So they're worth 20 points each. So if you know the easy parts, which is what I just gave you, you'll pass the course easily. You'll pass the final exam. Actually, you only need 50 because I gave everybody 10 points for the test I never gave. So you already got 10 points, and most of you got full credit for the labs. So most of you are walking in with 40 points already, or at least 30 or 40, between 30 and 40 points. So you really only need 20 to 30 points on the final exam to pass the course. So anybody that's shown up in class and studies a little bit will pass this class out there. So we don't need to worry. You don't need to worry about passing the course out there. Question 4. I'm not going to say a whole lot about other than Lab 2. Right there. Lab 2. Question 4 comes straight out of Lab 2. Right there. And I will tell you one part of the question right now. Right there. Worth 5 points. Write a program that will multiply two 8-bit numbers that are originally stored in memory locations A and B. You know, it doesn't matter. The numbers are here. And store the result in R0 and R1. Right there. That sounds a lot like Lab 2, right? One of the questions. Write a program that will add two 16-bit numbers. Sounds like Lab 2. Modify your program to light an LED if an overflow occurs. Part D is explain and show the process to multiply two 16-bit numbers. Now, Part D on problem 4 is really just knowing the process. And the process is actually the instructions in Lab 4, not your answer, but the instructions where you have to do 4 multiplications and add them up in a certain way. So if you look at Lab 2, if I can find Lab 2. I'm trying to find the Word document for Lab 2. It's posted, everyone's got a copy of it, so I'm not too worried about it. But if you look at the instructions for Lab 2, that's where the answer for that 4th part is. In other words, you don't have to write that long, drawn-out code to do the multiplication, but you have to tell me the process you would do that there. So, a flow chart or some instructions or the little table that shows how it's done, but you simply need to know how you would multiply two 16-bit numbers right there. As I said, question 4 is considered to be a more difficult part because you're asked to write code, and when you get into a final exam, you don't have sample programs. You'll have one sample program, but writing code on a final exam is very difficult. That's why I don't ask people to write a lot of code, but problem 4 is code writing right there. So I suspect that some people will do very well in problem 4, most will probably not. It's geared to where if you don't do well on problem 4, you'll still very likely get a B or a C or possibly even an A in the course. But in order to guarantee yourself an A, then of course problem 4 is one of the ones that it's worth 20 points out of the final exam, which is worth 60 points. Whatever 20% of 20 points, it's worth 12 points on your final score. Right there. So, problem 5 is basically 2 parts, and I'm about ready to wrap up here. Problem 5 has got 2 parts. So this is problem 4, and I just said Lab 2 right there. That's the only thing I can say about problem 4. It's coming all out of Lab 2, right there. Problem 5 has got 2 parts. And that's there. Problem 5, the first part is you're giving a program. I'll tell you right now, it's a modified version of Blinky or Blinky, and you're asked what various lines of code do. and you're asked to modify the code to change the flashing rate or things like that there. So in other words, you're asked what the program does and how you modify it. So again, right there, just simply say, explain the function of the program, assume that green LED points to green LED, explain the purpose of the command, that there is executed, modify the program to half the time between events, and I don't tell what the events are, but it's blinking the light. Modify the program to light the green LED only when there's a push button that's there. In other words, use an input right there. So again, as we look at, and boy, there's another little mistake there. There's two part D's. It's supposed to be part A, part E, but then the last part of that is write a short program similar to what I gave the other day in class, where you have a heating element or a tank, you keep it temperature, an air conditioner controller, you have some inputs that go high and low, and you want to turn on the aircon or turn on the heater in a certain situation, turn it off in certain situations, but it's a control problem right there. And I did an example of one in class the other day, but that's worth 10 points, which is right there. That's worth 6 points on your final grade right there when it's all said and done. So that is the final exam. That is the final exam. And I know that is the final exam because as I was going through telling you each question, I was looking at the final exam. And I keep this thing fingerprint locked. So that there. So don't steal my tablet to try to get a copy of it. You won't get it out. That there. But the final exam has been written. I went through the final exam. It's been submitted. It's been through the venting process. I don't know how these mistakes got missed in the venting process. There's a couple typos. Only one is serious, and that's the S move. There is no S move command. So if you see an S move on the final exam, and I'll announce it during the final exam, that change that to just move, or move C or move X or whatever it is, right there. But that there. The fact that the numbering's continued from the previous part, that doesn't matter. You still answer all the questions out there. So that's the final exam. I've covered everything on the final exam at least once. Most of the stuff on the final exam, I think I've covered 3 times out there. So you should not have problems with the final exam if you study. You've got 3 weeks to study this, and I told you what it is. I am available next week during class times. I will show up during class times. If the room is empty, I'm going to go away. Except for maybe next Wednesday. If I don't hear from anybody by before next Wednesday, I may not even come in. Because this is the only class I have on. Well, actually, I have to come in next Wednesday because we've got the FYP 1 presentations I've got to watch. So I will be here next Wednesday anyway. But I may come in later in the day. I may come because that won't start till 2:30. So I may come in just the afternoon on Wednesday. By the way, I'll just put it out there. I'm going to hit the pause button.